All right, let's look at the homework 15.4, problem number 9. All right, so let's rewrite this double integral in polar coordinates. All right. All right, so we need to know the region here. So I'm going to try to draw. Let's see, here's the x-axis. Here's the y-axis. All right, and here looks like this is going to be a semicircle. It's the left semicircle, so it's going to look like this. It's going to the radius is looks like A, and centered at the origin. So it's going to look kind of like this. All right, so it's going to look like this. All right. All right, then since y is going from 0 to a, so which means that we are only looking at the quarter circle, quarter disk here. All right, so just this much. All right, so we can just go ahead and rewrite it in terms of in polar coordinates. So you have a double integral. All right, so we're gonna do, let's see, so we're gonna have 8. So x is r cosine of theta, but we have to square that, so it's gonna be r squared and cosine squared of theta. All right, then you have a y, so that's going to be r sine of theta. All right. And then, let's see, we have dx dy, so in polar coordinates it's going to be r dr d theta. All right, then here the region is this, so a radius is going from 0 to, so if you fix the angle theta, so here, so here's the angle theta. All right, then the radius is going from origin, which is 0. So, and then here, A. So R is going from 0 to A. And the angle is going to be, seems like starting from the angle there is theta is equal to pi over 2. And all the way to theta equals pi, right? So it's going to be, so pi over 2 to pi, right? Then this looks like a separable integral. So I'm going to do all the thetas here. So it's going to be here, pi over 2 to pi. All right, so the thetas, so you have a cosine squared of theta and a sine theta and d theta times integral from 0 to a. So let's see, we took care of cosine squared and sine of theta and d theta. Right, so what's left is going to be 8, right, so which we take care of that, and then you have r squared and another r and another r, so it's going to be r to the 4th power, and then we have dr, right, so dr, right. So let's see, for this one, I would probably use a substitution, and I'm going to let u be cosine of theta, then derivative of u with respect to theta is negative sine of theta. Right, then take the reciprocal of both sides. We have d theta over du, which is 1 over negative sine of theta. Right, then we can just multiply through by du. So we have d theta is equal to du over negative sine of theta. All right, then we have to do the convert the lower limit and upper limit. So theta is initially going from pi over 2 to pi. Then we have to convert that to u, right? All right, cosine of pi over 2 would be 0, right? Then cosine of pi is negative 1. All right, so we can write it as, so it's an integral from 0 to negative 1. All right, cosine is now u, so it's u squared. And I'm going to leave the sine of theta as it is for now. And d theta is equivalent to du over negative sine of theta. All right, then multiply by. So you have, this is an integral. So you have 8 times. Antiderivative is r to the 5th over 5. Then you are going from 0 to a. Right, then we can cancel sine of theta and the sine of theta there. Then I'm going to use this negative sign to switch the lower limit and the upper limit here. So we have to go from negative 1 to 0. All right, then we can just find the antiderivative. Antiderivative u squared would be u cubed over 3. Then you're going from negative 1 to 0, right? And then multiply by, right? So this one, we plug in a for r. So you have 8 over 5, a to the 5th power, right? So this is going to be, right? So you have plug in 0, so it's a 0 minus, right? And actually, you don't really need to write 0. So here, minus. Plug in negative, so it's negative 1 cubed is negative 1, so it's going to be negative negative, so it's going to be positive 1/3 times 8 over 5 a to the 5th, so which means that we have 8 over 15 a to the 5th, right? So let's type it in. So we got 8 over 15 a to the 5th. So let's check the answer. Submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.